Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So now you are watching me and my group members video on IC packaging. Before we go further, I would like to introduce myself and my group members.
This is my team members. From the left, Muhammad Alif Azanuddin Alias 1160301. This is me, one Fairuz Amani, Binti, one Yusoff 1170293, and the last one is Muhammad Imran bin Muhammad Ali 1171456.
This video will be divided into 3 parts, which is, for the first part is the traditional assembly and packaging, which is this part will be explained by me, and the second part is the advanced assembly and packaging, and the last one is flip chip package on package for mobile phone, and this is for the application. For the second part and the last part will be explained by my team members. Today we will look more on the back-end process of the IC manufacturing, which is for IC assembly and IC packaging. First processing step after wafer fabrication and singulation that enables IC to be packaged for system use is the IC assembly. And the IC assembly actually is divided into 2 parts, which is there is traditional assembly and advanced assembly. Integrated circuit must be packaged properly to protect from the environment and handling damage. Besides, the IC packaging is for the interconnection into signals into and out of the chip purpose. And lastly, the IC packaging is also for the physical support for the chip and for the heat dissipation. And as for my part, I will present to you about the traditional assembly and packaging.
First, we will go through the process of IC assembly. What is actually IC assembly? IC and final assembly separates each good die from the wafer and attach the die to a metal lead frame or substrate.
Now let's move on to the IC assembly process, which is after the wafer is already sorted and tested. This wafer will undergo the background process. During this process, the thickness of this wafer will be reduced since for the to allow the stacking and high density packaging in integrated circuit. And next is the die separation process, which is also known as die singulation. After this process, the die will be placed on the substrate, which is this process is called die attach. And the last process is the wire bonding. Wire bonding is to provide the electrical connection between the silicon chips and the external lid of the semiconductor device.
Wafers normally undergo a cleaning and surface lamination process prior to the actual backgrinding process. The backgrinding process is automatically accomplished by a grinding wheel. To remove debris from the wafer while backgrinding, the wafer usually washed continuously with the ionized water while undergoing the backgrinding process. Backgrinding process preferred in many cases because it is faster and less costly than the newer chemical or plasma etching processes that have been recently developed. But this process also applying mechanical stress and heat during the grinding and causing scratches on the backside of the wafer. This is the wire bonding process. This process is to enable an IC to be electrically interconnected to the package. The advantages of the process of wire bonding is, first is the flexibility, which is wire interconnects can span considerable distances and height differences between interconnect points. Besides, these advantages of this process is in process monitoring, which is during the wire bond process, a number of electrical and magnetic signals are being captured in real time. While the wire bond process is taking place, this allows for an immediate evaluation of the bond conditions and a judgment of bond quality. And This wire bonding also offers the ability to remove weak or failed wires on an individual wire levels and attempt rework. The con in using the wire bonding process is it is serial process of interconnection, which is wire bonding is serial in nature in that each bond has to be formed sequentially. And there also the contamination, which is contamination at either bonding interface can greatly affect the bond integrity. This applies to organic materials such as hydrocarbons and non-organic materials such as oxidation and dust. And next is this process need of the requirement for a stable surface substrate, which is during the wire bonding process, ultrasonic energy is applied under the pressure. The ultrasonic energy can cause harmonics that create resonance with the substrate surface. Excessive vibration of the substrate surface can negatively interact with the bond formation, leading weak or no stick bonds. Therefore, a product design guideline used during the development process may include providing a stable bond surface to ensure the highest success for wire bond process.
When the processes of final assembly finish, IC packaging encloses the die in protective package. The three types of IC packaging, which are metal packaging, plastic packaging, and ceramic packaging. Metal packaging was common in the early of the semiconductor history. It's still used today for discrete device applications and small-scale integrated circuits with low lead count and in application that requires electromagnetic. This type of packaging is a fracture toughness and a good thermal conductivity, but it has a disadvantage of in manufacturing cost, which is it is a high cost. In plastic package, the chip is encapsulated by a polymer, usually referred to as the encapsulant, which is plastic package are very popular in commercial applications because of their low cost and small size compared to metal or ceramic package. Besides, it is also compatible with most standard board manufacturing processes. Actually, issues with plastic packaging, plastic packaging is hygroscopic and literally absorb moisture to a level dependent on the storage environment. This moisture can vaporize during rapid heating, such as in a solder reflow process, and these stresses can cause package to crack. While ceramic packaging typically instead of are applications that require either maximum reliability or high power with hermetic seal. The advantages of using this type of packaging is the circuit die does not come in contact with ceramic packaging material, and it also has high melting temperature, whereas the disadvantages of this packaging, it is more complicated and high cost in manufacturing process. The availability of this packaging also limited and has a low fracture toughness.
Assalamualaikum. My name is Muhammad Imran bin Muhammad Ali. Today, I will show you my virtual partner, Imran. Hi. Assalamualaikum everyone. Today, both of us will talking about advanced assembly and packaging. Okay, let's start with its type. It has 7 types of advanced assembly and packaging. First, flip chip. Second, BGA, which is ball grid array. Third is chip on board, COB. Fourth is tape automated bonding, TAB. TAB. And 5, multi-chip module, MCM. 6, chip scale package, and last is wafer level packaging. First is flip chip. This technology is invented by IBM, International Business Machines, in 1960. This technique uses 5% tin and 95% lead. Here are the advantages of flip chip. First is smaller size. As flip chip remove bond wires, it is reduced the area, almost 95%, and the weight is 5% lesser than the package device weight. Second is highest performance. Since eliminating bond wire reduce the delaying inductance and capacitance of the connection, flip chip offers the highest speed electrical performance. Third, flip chip give a greatest input and output connection flexibility. Next one is most rugged or high reliability. For example, they have survived laboratory tests simulating the forces of rocket lift-off, as well as millions of cumulative total hours of actual use in computers. Flip chip also can be the lowest cost interconnection for high volume automated production. So what about disadvantage, Imran? Flip chip has several disadvantages as well. The lack of carrier means they are not suitable for easy replacement or manual installation. They also require very flat surface to mount to, which is not always easy to arrange or sometimes difficult to maintain as the board heat and cool. Also, the short connections are very steep, so the thermal expansion of the chip must be matched to the supporting board or the connection can crack. Okay, let's move to the second one, which is ball grid array, VGA, surface mount packaging type. Most popular advantage is have high interconnection device. The advantage is better heat conduction. It has lower thermal resistance between the package and the PCB. This allows heat generated by the integrated circuit inside the package to flow more easily to the PCB, preventing the chip from overheating. Second, low inductance leak. When they have short distance between package and PCB, the inductance will decrease. The electrical performance becomes better. BGA, with their very short distance between the package and the PCB, have low lead inductance, give them superior electrical performance to pin device. Third, high density. BGA are solution for production of miniature packages for an integrated circuit with hundreds of pins. BGA does not have the common issue of adjacent pins bridging together when the solder is factory applied to the package. Thank you for the advantage. For the disadvantage of BGA is it was difficult to inspect. This is because solder connection cannot be visually inspected, otherwise it requires X-ray BGA inspection. BGA also cannot be reused, and it have more prone to stress because of flexural stress from the circuit board, leading to potential reliability issues. To solder BGA packages, an expensive equipment is required. Thus, hand soldering BGA packages is very difficult and unreliable. Next, we move on to chip on board COB. COB is a chip that placed on board and direct chip attached. It covered by epoxy. The advantage of COB package is ultra thin. With the COB, the thickness of the PCB board from 0.4 to 1.2 mm can be reduced to at least 1/3 of the original traditional product. Thus, it's very thick. Second is anti-collision and compression. The third advantage is COB has a large viewing angle. The COB package uses shallow well spherical illumination, which the viewing angle is greater than 170 degrees, close to 180 degrees, and has a better optical diffuse color twilight effect. The fourth advantage is bendable. Bendable is unique feature of COB packaging. Next one, COB has a strong heat dissipation, and it also has all-weather excellent characteristic. Okay, for COB package disadvantage, first, the package density is slightly smaller than the TAB and flip chip bonding technique. Second, need to be equipped with another welding machine and packaging machine. The production technology requirements are extremely strict. If sometimes the speed cannot keep up and the PCB patch is more stringent and cannot be repaired. Okay, the number 4 is tape automatic bonding, TAB. This mounting a die on flexible tape, which has two methods: single point thermosonic bonding and second gang or thermocompression bonding. Tape automatic bonding offers the following advantages. First, it allows to use of smaller bond pad and fine bonding piece. Second, it allows the use of bond pad all over the die, just not on the die periphery, and therefore increase the possible interconnection count of a given die size. Third, it reduces the quantity of gold needed for bonding, and lastly, it has a shorter production cycle time, result in better electrical. On the other hand, tape automated bonding has the following disadvantage. First, time and cost used to fabricate the tape. Second, we need to tailor fit the tape pattern after each die. And third, there are capital expense for TAB equipment, since TAB manufacturing require a set of machines different from those used by conventional process. Here we move on to multi-chip module, MCM. There are three types of MCM: MCMD, MCMC, and MCML. MCMD is interconnect substrate fabricated with employing thin film technology with deposited conductor, while MCMC is coal-fired ceramic tape processes, and MCML interconnect substrate fabricated using organic laminate PWB process. The advantages are lower power consumption, where smaller device resulting in lower power consumption. Next is mid-single application. MCP always the integration of chip made from different technology in one package. Lower cost. Cost saving is result from fewer packages with a fewer number of leads and simplified board layout. However, the disadvantage of manufacturing issue associated with MCM module include availability of unpackaged die, how to test, inspect the die, and test of MCM module. Thank you, my friend. The second last is CSP, chip scale packages. 50 different types of CSP available through the industry, and the number are increasing almost daily. It compares second level packaging efficiency. CSP packages have the following advantage. First, smallest footprint per interconnection resulting in significant PCB space saving. Second, very good electrical and thermal performance compared to plastic over molded packages. Third, utilize standard surface mount assembly technology. Next, proven board level reliability (BLR). For this advantage is limited package assembly data availability, moisture sensitivity, thermal management that have high interconnection. I think we at last type what it is. Yes, the last one is wafer level packaging. Wafer level packaging, WLP, is the technology of packaging the die while it is still on the wafer. The advantage is reduced parasitic inductance, reduced parasitic capacitance, and reduced testing time and cost. The cost and time involved in electrical testing is lower, as these packages are basically built with DFT in mind. Next is reduced cost per interconnection. Next, easier tracking back to the wafer. Next, easier inventory management. Tracking and managing inventory is much easier because all metallization, packaging, and testing procedure can be performed in the fab. Wafer level packaging technology still has lot of improvement. The application is not yet too encompassing since it currently applied primarily to small packages with low interconnection count, such as those used in analog, linear ICs, certain type of memories, integrated precision device, and certain type of controllers.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, now let's move on to the task number 3. Before that, I am Muhammad Alif. The topic I choose is flip chip package on package for mobile phone application. So, as we all know, with the rapid technology development in the semiconductor industry, the mobile phone has evolved from a simple communication device to a complicated and highly integrated system with multiple function and heterogeneous device. Based on the fast growth in emerging market for mobile application, many wireless devices have jumped to 4G long-term evolution as known as 4G LTE communication platform and have been ramped to 5G generation today. Then, moving forward with this trend, packaging semiconductor device for mobile electronic is more challenging than ever before, as the demand of higher performance, higher bandwidth, low power consumption, and smaller form factor are increasingly required in portable mobile device. So, the standard flip chip package are not able to meet this requirement. So, the solution is from the wire bonding package to the 3-dimensional or 3D package-on-package solution with flip chip interconnection or known as FC port has been widely utilized to successfully achieving these goals. With the ability to stack a logic processor and memory device in a single package, the utilization of FC port is becoming a preferred solution in the mobile market segment. It is well known that FC port technology development are related to the evolution of mobile low power double data rate, as known as LPDDR memory, which is requiring lower voltage, lower power consumption, and higher transition rate. Okay, now let's move on to the characteristic of FC pop or the technology of 3D FC pop. So the first characteristic is highly integrated, second low profile, third cost effective, and the last one is miniaturized. So these 4 characteristics is the benefit for the chip packaging. Then this is the structure of FC pop. Okay, now let's remind back our memory the meaning of FC pop. So the FC mean flip chip and the pop mean package on package. So from the structure we can see have to package in a single package, which are top package and bottom package. So in the structure also we can see the flip chip that attached to the substrate that causes the shortest path from the chip device to the substrate. So just now we have discussed all overall about the standard FC pop, but now we want to enter to the vehicle of FC pop that very important to the application of mobile phone. The vehicle for FC pop that I have studied which is iPop, also known as interposer pop. So the interposer pop or iPop will build a strong package solution if wide in out count and large die size is needed in a package, which is mean demand for higher level integration. Then the characteristic and also can be a function of iPod that we must to know and understanding, which is have a substrate that named as a top interposer substrate. So the first function of the substrate of top interposer to make connection for top and bottom package, and then the top interposer substrate using copper column or can be using copper core solder bore or can be using solder bore. And then the third function of the top interposer substrate is to design in different top and bottom ball pitch, and the last one function to the top interposer substrate, which is to reduce the warpage and coplanarity. So this is the structure of iPop of FC pop. From the figure 2 we can see pop B, which is mean the pop bottom, and the pop bottom having interposer substrate which is the green color at the top, and as I said earlier, the interposer substrate is to make connection of the bottom and top package. So the die size limitation overcome by using finite interconnection pitch, which can be termed by port B TBP, which is the TBP mean top ball pitch, and the top ball pitch of the top interposer and bottom substrate is 0.25 mm, and the top package height of this package is less than 1.2 mm and below. From the figure 1, we can see the combination of top package and bottom package. So for the top package, we can see it having the start of memory device, and its interface pitch can be 0.65 mm or can be 0.50 mm. So for the bottom package is about an application processor or a baseband device. So in this bottom package, FC port will allow potentially lower package height, which is maximum 0.69 mm, and the nominal thickness is 0.64 mm. So from the structure of iPod, we can conclude that the combination of the top interposer substrate and the flip chip is very important in the making of the system of mobile phone. The function of the flip chip is to reduce the package, and the function of top interposer is to making the system to be complicated. Then let's move on to the result of this type of packaging. So the left figure illustrates the package level reliability result of three different type of CCB interconnection, which is mean the copper core solder ball. So this figure clearly shows that there is no interconnection damage occur through this cross-sectional view, which is in the 15 x 15 mm of iPod package, and then 0.35 mm of TBB. Okay, alright. Now we continue to the right figure. So the right figure show us about the result of warpage. That I have said before, the warpage have been reduced by the top interposer substrate. So the figure illustrates the corresponding maximum warpage behavior. That shows the maximum warpage value was well controlled to be less than 40 micrometer at high temperature and meet the specification. And the maximum usual value for other vehicle of the iPod, which is can be maximum at the 80 micrometer at high temperature. Okay, this is the last part, which is conclusion. So for the conclusion, I will talk about the disadvantages first. So for the first disadvantages is higher profile, which is the top interposer substrate will increasing the height of bottom package, and the thinner bottom substrate will cause the last warpage and coplanarity. But in the advantages, because of iPod utilize thinner bottom substrate, it will compensate increment of package height by the top interposer substrate, and then by using the top interposer substrate, it will compensate the last warpage and coplanarity by the thinner bottom substrate. By these two advantages, I can conclude this system of the package is a stable system or stable package. And also for the other disadvantages, which are like wide in-out memory, large die size, higher performance, higher bandwidth, low power consumption, and multiple function. So that's all from us. Thank you.